Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you welcome back to this study. Dear student, this second video lecture of week 4th for the course Biostatistics 1 is the continuation of my previous first video lecture of week 4th. In the first video lecture, we have already discussed measure of central tendency. Dear students, there are different methods to compute the central tendency of any data known as measure of central tendency. These measure are arithmetical measure. In arithmetical measure, we measure the central tendency by arithmetic mean, geometric mean, and by harmonic mean. And the second one is a positional measure. In the positional measure, we measure the central tendency by median and by mode. In the first previous video lecture, we have discussed already measure of central tendency by mean. Now today in this second video lecture, we are going to learn about measure of central tendency by median and mode. In these two measures are called positional measure.
Or for raw data. How to find the median for ungrouped data and for raw data. Ungrouped or raw data, arrange for the ungrouped and for the raw data. First of all, arrange the given values in the increasing or decreasing order. If the number of values are odd, then median is the middle value of the data after writing in increasing or decreasing order and ascending or descending order. If the number of values are even, then median is the mean of middle of two values. For example, by formula, the median position is equal to n plus 1 divided by 2 items. A number lies on this position is called the median. So if the number of terms is odd, then we can find the median position by this formula n plus 1 divided by 2. And if the number of term is even, then we can find the median position by simple n divided by 2. So this is actually this formula actually represent the position of the median value, actually represent the position of the center value. First of all, indicate the position of the center value. So median is the most meaningful measurement for the central tendency. Actually, in the arithmetic mean. For the arithmetic mean, the order of the data is not necessary. But for the median, the order of the data is compulsory. First of all, write the data in order, in ascending order or in descending order. And then uh, uh, divide the data into two portions. The middle value, the center value will be the median. So if the number of term is odd, then there will be one single value of median. And if the number of terms in the data is even, then there will be two center values. And adding these two center values divide by 2, you will get the median for the data. For example, we have data 25, 18, 27, 10, 8, 30, 12, 20, and 53. First of all, arrange the data in ascending order. You see over here 8, 10, 18, 20, 25, 27, 30, 42, and 53. So there are actually 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 terms mean in the two portions. One portion contain the four numbers 8, 10, 18, 20, In other portion contain the four numbers 27, 30, 42 and 53. So this number lies at the center point. This 25 numbers lies at the center. This number lies at the center. And you see over here, in the first portion we obtain these number, and in the second portion we obtain these numbers. So 25 at the center, lies at the center. So this is actually the median for the data. But first of all, use this formula n plus 1 divided by 2. This formula represents the position of the terms, the position of the median. N plus 1 divided by 2 represent the position of the median term. So there are n values. So 9 plus 1, 10. 10 divided by 2 is equal to fifth. So at fifth position we obtain the median. So 1, 2, 3, 4, 5. So at this fifth position we obtain the median, which is 25. But if the number of terms is even, suppose we put here one another number like 60, then five terms will be on the other, four terms will be on the one side and four terms will be on the other sides, and we obtain two terms at the center. So at this center point we obtain two values. So adding these two values divided by 2, we will obtain the median for the data. So dear students, n plus 1, n n divided by 2 represent the position of the median when number of terms in the data is even, and n plus 1 divided by 2, this formula represent the median term position when the number of values in the data is odd. Why we put uh, n plus 1? Why we add 1 with the total number of terms? Actually, position, we present the position in the whole number, not in decimal form. For example, n is equal to 9. There are 9 terms. You see over here in this example, 9 divided by 2 mean 4.5. We cannot present the position in the fraction in the decimal form 4.5. We say that position first, position second, third position, fourth position, fifth position, sixth position, seventh position, and so on. So we call whole number for the positions. That's why we add this one when the number of terms in the data is odd. So dear student, this point is very important. For the median, first of all, write the data in order form and then use the formula for the position of the median terms. First of all, indicate the position. At which position the median term is lies. First of all, indicate the position. For the position, use this formula n plus 1 divided by 2. This is the n plus 1 divided by 2 items. So when the number of terms in the data is odd, then indicate the position by this formula n plus 1 divided by 2. And if there are even number of terms in the data, then for the position use the formula n divided by 2. Now the median denoted by, we can denote the median by MD, is the middle values of the sample, where the data are ranked in order according to size. Corner has defined as the median is that value of the variable which divides the group into two equal parts. And I have already told you in the previous slide that median divide the data into two equal parts, one part comprising of all values greater and the other all values less than median. For ungrouped data, median is calculated as you see over here in this example. In the previous example, you see over here median calculated as, first of all, write the data in order form and then divide the data in two groups. You can easily find the middle position. If the number of data is odd, then you will obtain a single number at the center position after dividing the data in two portions. But if the number of data is in even, then you will get two terms at the center position after dividing the data into two parts, and then simply add the two terms, divide by 2, you will get the center points of the data. Now example number 2, you see over here, this is the ungrouped data. According to the census of 1991, following are the population figures in thousand of 10 cities are 14,000, uh, 1250, 12,050, 16, 1,250, 1,670, and 18,700, 650, 570, 488, and 2,100, 1,700. To find the mean, arrange the data in ascending order like you see over here. First of all, write the data in the order form. Here you see over here the number of data is 10, which is even. Therefore, the median is the mean of the measure of the fifth and sixth terms. Fifth and sixth terms, fifth and sixth term. First of all, arrange the data in order form, and then construct the two parts of the data. These four terms will be on the one side, and these four terms will be on the other sides. And you see over here, there are two terms at the center point. So there are two terms at the center point. Now, adding these two terms, divide by 2, you will easily obtain the median for the data. Now, median in group form. The following data pertaining to the number of members of a family. To find the median size for this family, number of members x 1, 2, 3, 4, 5, 6, 7, 8, 9. Dear student, this data actually called the frequency distribution, and we can construct the group data for this example. But in frequency distribution, we can easily find the median as compared to the group form. How to find the median when the data is in frequency distribution? You see over here, there are some terms in this data, and these are the frequency for each terms. 1, frequency of 2 is 3, frequency of 3 is 5, frequency of 4 is 6, frequency of 5 is 10, and so on. The frequency of 9 is 3. So first of all, construct the table. For the table, write in the first column the values of the data. In the second column, write the frequency of the each values, and in the third column, write the cumulative frequency. So this capital N here represent the cumulative frequency. Write 1 as it is. 1 plus 3, 4, 4 plus 5, 9, 9 plus 6, 15, 15 plus 10, 25, 25 plus 13, 38, 38 plus 5, 43, 43 plus 9, 52, and 52 plus 3, 55. This last number represent the whole number. This last number represent the total frequencies, the sum of the frequency. This last number represent the total values of the data. Then the cumulative frequency column will be true. Now, first of all, find the position of the median terms. The position of the median term is equal by the formula size of the n plus 1 divided by 2 item. Actually, 55 is odd. There are odd values in this data. So 55 plus 1 mean 56, and 56 divided by 2 give the position of the data 28th position. So at 28th position, there are the center tendency which called the median. So you see over here, the capital N represent the cumulative frequency, and cumulative frequency actually represent the positions. One mean at the first position, this number lies. Similarly, from position number 2 to position number 4, this term lies. And from position number 1 to 4, this number lies. From position number 2 to 4, this number is lies, and from position number 5 to 9, this number lies. Similarly, from position number 10 to 15, 4 lies, and from 16 to 25, 5 lies. Similarly, 6 lies at the position from 26 to 38. So from 25 to 38, we can say that from 1 to 4, this number lies, 4 to 9, this number lies, 9 to 15, this number lies. So from 25 to 38, number from 26 to 38 lies 6. From 26 to 38, the number value 6 is lies, and we have the position of the data. The position of the data, we have the position of the data is 28. So you see over here, at this position from 25 to 38, from 26 to 38, from 26 to 38, there are 28 position. So at the 28 position, 6 is lies. So 6 is actually the median for the data. Now, median for group data. Median for a group data can be found by the formula L plus H divided by F into N by 2 minus C, where L is the lower limit of the class at which median lies, H is the step size of the class, F is the frequency of that class at which median lies, and N is the total number of frequencies, sum of the frequency. C is the cumulative frequency in this formula. For example, you see over here we have classes data 30 to 39, 40 to 49, 50 to 59, and so on, 9 to 99. And these are the frequencies. So how to find the median for this group data? You see over here, write in the first column classes, and in the second column write the boundaries of the classes, continuous boundary for the mode and for the median, since we discuss the position. So for the positions, for the position, first of all, write the classes in continuous form. The first class last boundary is 39, and the first boundary of the second class is 40. So this is a discontinuous boundary. If the last boundary of the first class is 39 and the first boundary of the second class is also 39, similarly 49 and 49, 59, 59, 69, 69, 89 and 89, then the classes will be continuous. But this is a discontinuous data. So first of all, obtain the continuous boundary for this data. For the continuous boundary, subtract 0.5 from this class limit and 8.5 to this class. Subtract 0.5, we obtain 29.5. In 8.5 to this class, we obtain 39.5. Similarly, subtract 0.9 for the lower limit and 8.9 to the upper limit. You see over here, now the data is in continuous form. So these are called the class boundaries. Now find the class midpoint of each class. Add these two boundary divided by 2, you will obtain the midpoint of each class. And now frequency of each class which is given, and now the cumulative frequency 8 is 8. It is 8 plus 87, 95, 95 plus 180, 285, and 285 plus 304 is equal to this. Similarly, you see over here, these are the cumulative frequency. Now obtain the position of the median n by 2, because there are even number of total values. You see over here the n is 905. 905 actually the r term, 905 is the r term. So for the median position, 905 plus 1 divided by 2, we obtain 45th position, 453 position. And 443 position students, which corresponds to the marks in the class, 453, 453 lies in this position, 453. From 286 to 583, this class is lies, 59.5 to 69.5. So median lies in this class. So first of all, indicate the median class. Now this is the median class, this is the midpoint of the class, and this is the frequency of the class at which median lies. Now using the formula, the lower limit of this class is 59.5. The step size of this class, the step size is 0. The step size is 10, and the cumulative frequency for this class is 285, and the frequency of this class is 304. Now putting all the values, this is the lower limit plus step size divide the frequency and the total n divided by 2, n divided by 2 mean 905 divided by 2 mean 452.5 minus the cumulative frequency, and after simplifications we obtained the median is approximately 65. Now you see over here, this is the another example, marks of the students in the group form and number of students and the cumulative frequency. But dear student, first of all, write the class boundary for each class and then find out the class of the median h width median lies. So 14.4, actually at this class the median is lies of 41. 41 is the cumulative, these are the cumulative frequencies, these are the cumulative frequency. In this data we obtain 50 students. So 50 divided by 2, 25, and 25 position lies in this group. From 25 to 41, this class is lies. So in this class there are, and the median lies in this class. So the lower limit of this class after continuous boundary 14.5. And now the cumulative frequency is 24. So the lower limit of the class is 14.5 and the step size is 5, frequency is 17, and total number of turns is 50 divided by 2 minus the cumulative frequency 24, and after calculations we obtain the median is 14.94. Now the last terms of the central tendency is a mode. The mode denoted by MOD is the value which occurs most frequently in a set of measurement of our values. In other words, it is the most popular values in a given set. Croxton and Corton define it as the mode of the distribution is the value at the point with the item tends to most heavily concentrated. It may be regarded as the most typical of a series of the value. So mode is the value, most time repeated value is called the mode. Most time repeated values of the data, most repeated value of the data is called the mode for the data. For example, in a crash test, 11 cars were tested to determine what impact speed was required to obtain minimal bumper damage. To find the mode of the speed given in the miles per hour below, 24, 15, 18, 20, 18, 22, 24, 26, 18, 26, and 24. So after writing the data in the order form, you see here this is the order of its ascending order of the data, and this data 18 repeated 3 times and 24 also repeated 3 times. So the mode for this data is 18 and 24. But if there is no number repeated most time, then the mode for this data can be written as there is no mode. We don't write 0 is the mode. 0 means 0 is a number which repeated most time. So if any number does not repeat, then the mode for the data can be written as there is no mode. Just write the description that there is no mode. To compute the mode from the data 2, 7, 10, 15, 10, 17, 8, 10, and 2. And this data you see over here, 10 is repeated 3 times. 10 is repeated more times, so 10 is the mode for this data. Now to find the mode for the group data, when data are organized into group frequency distribution, the mode will lie in the class that carries the highest frequency. This class is called the model class. Then apply the formula L plus Fm minus F1 divided by Fm minus F1 plus Fm minus F2 multiplied step size of the class. L is the lower limit of the class, Fm is the maximum frequency, F1 frequency associated with the class preceding the model, and F2 frequency associated with the class following the model class, and H is the width of the class interval. For example, you see over here the marks in the class data and number of students represent the frequencies. So first of all, write the class boundary for each the class. Actually, these class in the discontinuous form, and these are the given frequencies. Now, the maximum frequency is 304, and the minimum frequency is 8. So you see over here the maximum frequency is 304, which correspond to the class 59.2.5 to 69.5, and the lower limit of this class is 59.5. Similarly, F1, this is actually the maximum frequency. From the maximum frequency, above represent F1 and below represent F2. So F1 is 190 and F2 is 211, and the step size for this class is 50. Now this is the mod formula, putting the values of L, F1, F2 and Fm and the step size in this formula, and now calculating the formula, we obtained the mod is 65. From this problem we obtained the median. The median is also 65, and now the mod is also 65. Now another example, you see over here, this is the group data and these are the frequencies. Dear students, try yourself for this example to find the mod. First of all, continues the boundary, and the maximum frequency in this data is 8. So mod lies will be in this class. Now f1 is f1 is represent 2, and this one represent the f2. So try yourself and put the terms values in the formula. You can get easily the mod result. Now advantages of mod. Mod is readily comprehensible and easily calculated. It is the best representative of data. It is not at all affected by extreme value. The value of mod can also be determined graphically. It is usually an actual value of an important part of the series. And there are some disadvantages of mod. It is not it is not based on all observations. It is not capable of further mathematical manipulations. Mod is affected to a great extent by sampling fluctuations. Choice of group has great influence on the value of mod. Similarly, advantages of median. Median can be calculated in all distributions. Median can be understood even by common people. Median can be ascertained even with the extreme items. It can be located graphically. It is most useful dealing with the qualitative data. And the disadvantages of median, it is not based on all of the values. It is not capable of further mathematical treatment. It is affected fluctuations of sampling. In case of even number of values, it may not be valued from the data. Properties of mod. It is used when we want to find the value which occur most often. It is a quick approximation of the average. It is an inspection average. It is the most unreliable among the three measures of central tendency because its value is undefined in some observations. Similarly, property of mean. Mean can be calculated for any set of numerical data, so it always exists. A set of numerical data has one and only one mean. Mean is the most reliable measure of central tendency since it can take into account every item in the set of data. It is greatly affected by extreme or deviant values, outlier. It is used only if the data are interval or ratio. Now, certain tendency in the shape of the distribution, because the mean, the median, and the mode are all measuring certain tendency, the three measures are often systematically related to each other. In a symmetrical distribution, for example, the mean, the median will always be equal, and if a symmetric distribution has only one mode, the mode, mean, and median will have the same value. In a skewed distribution, the mode will be located at the peak on one side of the mean, usually will be displayed toward the tail on the other side. The median is usually located between the mean and the mode. You see over here, there is some relation. In symmetrical distribution, the median and mode are equal. For non-distribution, mean is equal to median is equal to mode. In positively skewed distribution, the mean is greater than the median, and this is the representation of this positive skewed. In negative skewed distribution are the mean smaller than the median. This is the negative skewed distribution. And you see over here type of frequency distributions. when mean, median, and mode are equal, then the data will be symmetric distribution. And if median between mean and mode, you see over here, this is the negative skewed distribution, and this is the negative skewed distribution. Median, mode, and mean, this is the median. So mean is mode is greater than median and median is greater than mean, then this is the positive skewed. And similarly, mode is greater median lies between the mean and mode, this is the negative distribution. Mode is greater than median and median is greater than mean, this is the negative skewed distribution. And you see over here, in this case, all three central redundancies are equal. This is called a symmetric distributions. And in this case, you see over here, this is the positive skewed. And positive skewed, median lies between the mode and mean. Mode greater than median and median greater than mean. And this is the negative skewed. So in negative skewed, mode is greater than median and median is greater than mean. So the conclusion of this lecture is a measure of certain redundancy is a measure that tells us where the middle of the bunch of the data lies. Mean is the most common measure of certain redundancy. It is simply the sum of the number divided by the number of numbers in a set of data. This is also known as average. Median is the number present in the middle when the number in a set of data are arranged in ascending or descending order. If the number of values in a data set is even, then the median is the mean of the two middle numbers. Mode is the value that occurs most frequently in a set of data. So dear students, this is the conclusion of this lecture. Now this is the end of this segment.